For April 2025 holiday lessons. So this one is a summary of what we were covering in physics during the 2 weeks of contact in Glendale. So we are having our lessons in Glendale. So if you're a resident of Glendale and you do your maths, your physics, your chemistry, and you are not joining us for lessons, then you are missing out a lot. We are available at number 1572 Freedom Street, Highway, Glendale. Depending on our numbers, you might find us at the Glendale Church of Christ, Umuzi Farm. So you can always contact me for details if you'd like assistance. So we covered a lot during the 2 weeks that we had physical contact. We're just going to summarize that in this video. So the first thing that we talked about was distance versus displacement. So you must know the differences between these two terms as they are used in your O-level physics. So distance is the total length covered between 2 points. The total length covered between 2 points. You must know that it is a scalar quantity, meaning that it is a magnitude, a size, but it is no direction. Whilst displacement here is the straight line distance. So this is key, straight line distance in a specific direction between an object and a specific point. Your specific point here is your starting point. So it's a straight line distance in a specific direction. So we now have a direction. So this one becomes a vector quantity because it is a size, a magnitude, and also a direction. The SI unit for both distance and displacement is the meter. So let's compare and contrast these two terms using a diagram here. So we have a diagram here where we have a specific point here, our starting point P, and we have this path 7 kilometers, we have this path 10 kilometers, and we have this straight line distance here. So when we speak in terms of distance and displacement, what does this mean? So we have two possible routes here, path A and B. So your distance through path A is going to be 7 kilometers and your distance through path B is 10 kilometers. However, your displacement is the same in both cases. So you have a displacement here of 5 kilometers for path A, and you still have the same displacement, which is 5 kilometers for path B. So this is according to our definitions of distance and displacement. We said here, let me just take you back to the definitions. We said the distance would be the total length covered between 2 points. So we had 7 kilometers and 10 kilometers for path A and B. However, displacement would be the straight line distance in a specific direction between an object and a specific point. So you can see that the straight line distance here is the same whether you're looking at path A or B. The straight line distance between P and Q is 5 kilometers. Okay, so let's move on to talk about speed and velocity. So what is speed? This is the rate of change of distance. This is how distance changes over a period of time. We're looking at how distance is changing over a period of time. So the formula is distance divided by time. It is a scalar quantity. Speed does not care about direction. It is just the rate of change of distance. However, velocity is the rate of change of displacement. Now, displacement is changing over a period of time. Now, remember, displacement has direction. It is a vector quantity. So when you speak of velocity, you're not talking about displacement, which we said in the previous diagram here. It has a specific direction, that is from point P to Q, or it can have a negative direction, which is from Q to P. So you have to specify the direction. So velocity, when you speak of velocity, you're now taking into account the direction. So we are saying velocity is the rate of change of displacement. So velocity is equal to displacement over time. It is a vector quantity, unlike speed, which is a scalar quantity. The SI unit for both speed and velocity is the meter per second. Okay. So let's talk about uniform or constant speed. So the speed is constant or does not change throughout the whole journey. So when you are moving at a constant speed, we say you are moving at uniform speed. And as before, our speed is measured, is calculated using distance over time. For non-uniform or non-constant speed, we have to determine the average speed. We have to determine the average speed. For example, one might start off with a specific speed, let's say 10 meters per second, and later on they might increase that speed to 15 meters per second. And now for the whole journey you're asked to calculate the speed, then you have to look for the average speed, in which you say the total distance traveled over the total time taken. So you just look at the total distance versus the total time, and you get your average speed. So we'll look at a question in which we use this formula. Okay, when the speed of an object is 0, it is at rest. So when we say something is at rest, remember that its speed is 0. Its velocity is 0 as well. Okay, so let's now look at this example. George drives a car from town A to town B. So you can see here we are starting at a specific point, town A to town B. It's an average speed of 80 kilometers per hour. It is known that the distance between the two towns is 180 kilometers. Okay. In the next day, George drives back from town B to town A at an average speed of 90 kilometers per hour. So you can see that George here is now traveling back. The direction has changed. His speed has also changed. He's now moving faster at 90 kilometers per hour. Calculate the average speed of the car for the whole journey. So we now use that formula that we talked about, where we have to look at the total distance traveled divided by the total time taken. So here we have to calculate the time it took for him to travel from town A to town B. So our time here, when we rearrange this formula for time, we get distance over speed. So we had a distance of 180, and it took him, he was using a speed of 80 kilometers per hour. So it took him 2.25 hours to travel from town A to B. Now from town B back to town A, the distance is still the same, 180, but now the speed was 90. So it took him 2 hours. So the total distance now for town A to town B, that would be 180. However, moving backwards from town B to town A, that's another 180. So 180 plus 180, that would be your total distance for the whole journey. Now, the total time is now your 2.25 here plus the 2 hours here, and now we have an average speed of 84.7 kilometers per hour. Okay, so this is when you have non-uniform or non-constant speed. You see that he was using 80 kilometers per hour, and then later on he changed to 90 kilometers per hour going backwards. Okay, so let's now talk about acceleration. What is acceleration here? It is the rate of change of velocity. The rate of change of velocity. So your velocity is changing over time. So the rate at which it changes would be our acceleration. It is a vector quantity, meaning that it is a direction. The unit is meters per square second. So acceleration is calculated using this change in velocity over time taken, or delta v over delta t here. Okay, where you can say here your final velocity minus your initial velocity over change in time. Okay, so this is the formula for that. So let's talk about deceleration, which is used to describe an object moving at a decreasing velocity. So when the velocity is decreasing, we say there's a deceleration. It can be interpreted as negative acceleration. So for example, when the brake of a car is applied, its deceleration is 5 meters per square second. So this is what you can say, or it has an acceleration of negative 5 meters per square second. So let's meet in the next video where we continue with this.